Hello my students, welcome to my channel, my target 100%. I think all of you have must seen my last videos. Dear students, if you will not continue the video, you will not watch one, you cannot understand the another one. Life is a continuous process, systematic. You must be disciplined. Okay? Once you neglect anything which is important for you, that makes your career, make your life, and it will spoil your life, because habit is mainly two types: good habit, bad habit. Try to maintain good habit, because good habit makes you, bad habit spoil you. Anyway, so today's topic is numerical problems on center of mass. Let us discuss numerical problems on center of mass. Numericals on center of mass. As you know, the center of mass of position vector of two particles RCM is equal to, that you have to repeat based on this one, M1 R1 plus M2 R2, okay, vector, position vector, and M1 plus M2, that you will use. Okay, before going to start the numerical problems, that you must know, while you start the numerical problems, what are the important steps involved, necessary, while you are going to solve numerical problems. That I have already made one video. The following steps are required. Today also I am repeating the same. You read the question thoroughly first. If you are not understanding, again you read at least 2 to 3 times. Once you understand, so it is okay, no problem. If you are not understanding, try to read again and make it into your own language. Whatever the language may be, we are speaking English, okay, Hindi, whatever, but in your mother tongue, it is best for your understanding, because mother tongue is the best expression and understanding for expression and feelings, realization. Okay, then anyway, third point is collect the data, what are the given in the question. Fourth point, try to make the whether the system of units are same or not. If system of units are not same, convert it into one another, means make it into one system of units, then it becomes easy for you. Then if fifth point, if it is directly formula based, just you write the formula and put the value. If it is not directly, so what you will do? So you will find one another or one which is essential for finding the value. After that, but sixth point is, after putting the value, don't write the last, the conclusion point, you simplify it, at least two points, 2 lines you simplify. After that you write the last point, but don't forget, not last point, not least, this one is, suppose RCM and you are taking the SI unit, you will write this is 0.4 meter, and if you will not write the mention the unit, your marks will be cut off or reduced. Okay, these are the following steps. Please you maintain it and remember it. So today's numericals based on center of mass. First one is, consider 3 particles of masses. Listen the question. 3 particles, M1 1 kg, M2 2 kg, M3 3 kg are placed in the 3 corners of an equilateral triangle. So find the coordinates of the center of mass of the system. Okay, what it is? So given, I am not writing the question is I am repeating, and given M1, you can easily understand, 1 kg, M2 2 kg, and M3 3 kg. R is equal to, that is distance, you will understand after drawing the figure. Suppose this is x axis, okay, this is y axis, and you are making one equilateral triangle, 3 corners, okay, this one is, you give A, this is B, this is C, equilateral triangle, so all sides are equal, and it is given 1 meter, it is 1 meter, it is 1 meter. Okay, then what will do? Side is given, mass, suppose this one is M1, okay, this one assume M2, this one is M3. You have to calculate the center of mass of the system, means along x axis, along y axis, as it lies on the xy plane. Okay, come to point. Suppose you will calculate xcm. You know, along x axis m1 x1 plus m2 x2 plus m3 x3 divided by total mass m1 plus m2 plus m3. Okay, so in this way what will do, you only m1 m2 m3 is given here, clear, but only to find the position. As it is 0, suppose coordinate is x1 y1, so coordinate is 0 0, both are situated on the origin. This one is lies on the x axis, so this one is x2 y2 and this is 1 0. Why? Along x axis, suppose this one is AB, this one is midpoint. Suppose draw better for understanding this one, it is D. Okay, if this one is 1 meter, so this is half meter, you can write 0.5 meter. Okay, then how can you calculate this one? And now this one is perpendicular. Now this one ADC is a right angle triangle. Okay, can you understand? This is 1 0. You will calculate x3 y3. Along this one is x3, so it is 0.5. And how can you calculate this one? Suppose CD, you give the name E. So in ACD, in ADC right angle triangle, what you are getting? SC is equal to, this is H, this is P, this is B. So H is equal to how much? P square minus B square square root. So this is this one you will calculate, sorry, SC is given, that is a CD. You have to calculate CD. CD is equal to SC square minus AD square, correct? SC square AD square square root. So SC is how much? 1 square, that is 1. AD square, you put the value 1 square minus 1 by 2 whole square, that is this one. That means 1 minus 1 by 4. This one, this is 4 minus 1 by 4. This is, so 4 minus 1 by 4 square root, that is root 3 by 4. Okay, square root. So that means root 3 by 2 is another coordinate. So it is root 3 by 2 meter. This one. That means one is 0.5, another root 3 by 2 meter. Anyway, now put the value here. X1 is equal to 0, x2 is equal to 1, x3 is equal to 0.5. Okay, this. Now put the value only put the value. M1 is that one in previous, that I have already erased, into 0 plus M2 2 into 1 plus M3 3 into half by M1 1 kg, M2 2 kg, M3 3 kg. So how much it is? 6. So that means 2 into 1 2 plus 3 by 2. This is 2 plus 1.5, that is by 6, that is 3.5 by 6, that means 35 by 60. So 35 by 60, if you give that one, give decimal, so it is 350. So 6 5 jai 300, then 500. So this is 8. So now you are getting this one, XCM. The coordinate system along the x-axis, you are getting this one. Similarly, YCM is equal to M1 Y1 plus M2 Y2 plus M3 Y3 divided by M1 plus M2 plus M3. Okay. Similarly, put the value here y1 0, 1 into 0 plus this one is y2 2 into 0 plus M3 3 into root 3 by 2. This is important. 3 into 3 by 2, that y3. Then it is 6. So what we are getting? 3 by 2. It is 3 root 3 by 2. 3 into root 3 is 1.732 divided by 2. So it is, you take 8666 divided by 6. Okay. So how much you multiply? 3 6 18, then 3 6 18, 9, then 3 8 so 24, that is 25. This much. If you will divide this one, you will get 0.4, then 19 19 19 6 3, then 3. Only you take 2 decimal. After decimal 2 digits you take. So that means this one. So at last you will write the center of mass of a system of 2 particles, or the coordinates. You can write the coordinates here. Okay. So how much it is? 0.58 meter, then another is 0.43 meter. This is the coordinate. Okay. Now what we will do? I am giving one numerical for you, which is based on homework, home assignment. Suppose mass M1, I am writing here mass M1. So M1 in place of M1 side, and I am changing the mass. M1 is M1, mass 3 particles mass is M1, M2 and M3 kg. Okay, 3 particles masses, and distance is A. Distance is A. Okay. Clear? So you will calculate the value or locate the center of mass of the system. That means same thing, in place of mass I am repeating the same, and side changing. The vertices of an equilateral triangle you are keeping. Then what will happen? Okay. Then another one is most important. I am reminding you, the most important thing is mass is given, but coordinates, that means x coordinate, y coordinate is not given. That you have to find. After finding, you put the value. Okay. Then another question. Suppose there are 4 particles of masses. 4 particles of masses. M1. Similarly, you take another problem. Suppose numerical 2. There are 4 particles of mass. M1 1 kg, M2 2 kg, M3 3 kg and M4 4 kg. Of you are placing the 4 vertices of a square of side 1 meter. Okay. Suppose this is x axis, you do, this is y axis. Suppose these are the 4 points of a square. Suppose this is A, this is B, this is C, this is D, and you assume D as the origin. DC you are taking x axis, and DA you are taking y axis. Clear? This is x1, y1, that means 0 0. Here it is x2, y2, it is 1 0. Okay. And this one is this place, you see what, this one is 1 1, because from this point you are taking A B C D. So this place, this much is x axis, there is no y value of y axis. This side, this is 1 1, this one is y axis, so it is 1 0. So no problem. How can you find the value of center of mass of the system? So in this case, just put the value I am giving for you. Okay. XCM M1 x1 plus M2 x2 plus M3 x3 plus M4 x4 divided by M1 plus M2 plus M3 plus M4. Okay. Any problem? I am writing here also. Here x1 0, okay, and x2 1, x3 1, x4, it is x4 y4, so it is 1 0, it is 0 1, it is x axis, x4, it is x3 y3, it is x4 y4, so it is what upon, so that you must contains that value, it is 1 0, it is 0 1, okay, so that means it is x4 0. Why? And this is y axis, first one, so in this case just put the value m1 1, x1 0, m2 just rapidly, okay, x2 1, m3 3, x3 1 plus m4 4, x4 0, total mass 4 3 7, this is 10. That means just 0 plus 2 plus 3 plus 0, so that is 10, that is 5 by 10, that is half, that is 0.5 meter. In this way, for you YCM you will calculate m1 y1 plus m2 y2 plus m3 y3 plus m4 y4 divided by m1 plus m2 plus m3 plus m4. Put the value, get the answer. And how much answer you will get, that I am telling for you, that answer becomes, the value of answer is becomes, as per the coordinates you are taking, you will get the 3 by 10, it is 0.3 meter, 0.3 meter, 0.3 meter, okay. So the coordinates of the center of mass of the system is 0.5 meter, 0.3 meter. Clear? So in this way you have to calculate the center of mass of the system using that formula. So another question I am giving for you, just you write that question is, numerical is, two particles of mass m1 100 gram, m2 200 gram, and the position vector is, just try to write that one. Okay, how much it is coming, just see. Suppose mass m1 is equal to 100 gram, m2 is equal to 200 gram, clear? Then r1 is given 2i cap plus 3j cap plus 4k cap, okay. r2 is equal to 3i cap plus 4j cap minus 5k cap, okay. So what you will do, this one, and respectively, and velocity is also given, v1 is equal to, this is the r1, this is r2, velocity is equal to 10i cap minus 7j cap minus 5k cap, velocity 2 is equal to 7i cap minus 9j cap plus 3k cap, respectively it is given. You have to calculate the center of mass of two particles, that means velocity of center of mass and instantaneous position. So what you will do, for that I am telling, okay. So that you have to apply. For position, instantaneous position, you will write RCM is equal to m1 r1 plus m2 r2 by, it is also given m1 plus m2. It is direct formula. That means m1 you have to put, just I am giving you, put this value m1 into this one, m2 into this one, okay. So after that, another formula will calculate velocity of center of mass m1 v1 plus m2 v2 divided by m1 plus m2. Similarly, m1 this one, then m2 this one. In this case, what you will do? You just simplify this one and you will get that answer. Just put the value. So don't think that sir is not doing that one. M1 you practice yourself. M1 into this one, M2 into this one. Similarly, M1 into this one plus M2 this one. You will get that coordinates and this one. In this way, you have to calculate the center of mass of the system. Whenever necessary, M1 V1 and you know K dot K 1, but in cross product I cap cross J cap, you will get K cap, J cap cross K cap, you will get I cap. In this way, if necessary, whenever necessary, dot product, cross product rule you use. And for coming video, don't miss that time. You join all of you. We have to discuss about the numerical problems on the basis of continuous body, if possible, and we have to discuss about the center of mass of a system of a rod. A rod lies on the x-axis. One side is connected with another origin, another is lying this side. That means when one side is lying at the origin, what is the center of mass? And if you are keeping that rod in between the axis, what is the value? After that, there is a continuous distribution of mass body. For continuous body, we have to solve some numerical problems. Thank you. Have a good day.